Alright, tonight what we're going to be talking about is percent composition. And percent composition, whenever we mention that in chemistry, is basically asking what percentage is a given element contributing towards the mass of that compound. It's the exact same way that you would solve for any percent. You would take your part over your whole and then times by 100. But what we're going to be using in this class is we are going to be using this basic percentage, which is the percent composition over 100. Once again, we're going to be doing proportions, is equal to the grams of whatever element I'm asking about over the molar mass of that entire compound. There are three basic questions or types of percent compositions that we can ask. The first one was when we ask you to find the percentage of each element when there are two or more elements in a compound. The second type is when you have to find the percentage of each element in a known compound. And the third type is when you're finding the mass of a single element in a known compound. Okay? And once again, you're going to be setting up proportions for all of these. So let's go straight away and start doing some practice problems. Alright, so it asks you to calculate the percent composition of C3H8. Whenever they ask you for a generic percent composition, what they're asking for is what is the percentage of carbon in this problem and what is the percentage of hydrogen towards the contribution of its mass. So we're going to set up the formula of percent composition over 100 is equal to the mass. And for this one, I'm going to start doing it with carbon. So we're going to do the mass of carbon. So what is the mass of carbon? Well, it is 3 times 12 because we have 3 carbons in C3H8. And we're going to divide it by the molar mass, which is 3 times 12 plus the 8 hydrogens, each with a mass of 1. So in reality, this is going to equal 36 over 44 is equal to your percent over 100. When you multiply, cross-multiply, and divide, what you get is that carbon contributes 81.8% of the mass to C3H8. Right? So to do hydrogen, what you're going to do is it's 8 times 1, or 8, okay, divided by the total molar mass of C3H8, which we already calculated was 44. That is proportionally going to be equal to the percentage over 100. So when you cross multiply and divide for this one, you get hydrogen is contributing 18.2%, which makes sense because if we added up the carbon's percentage with the hydrogen's percentage, we would get a total of 100%, which makes sense because the only things contributing towards mass in C3H8 are carbon and hydrogen. Alright, the next one says calculate the mass of carbon in 82 grams of C3H8. So what type of question is this? This is type 3. This is also one that my students struggle with the most. This is not going to be directly taking the percent composition formula. Instead, you're going to be taking a ratio. Alright, so what is that ratio? What we're asking for is, hey, how many grams of carbon are found in 82 grams of C3H8? Well, I don't know off the top of my head, but what I do know is that I have 3 times 12, or 36 grams of carbon in 1 mole of C3H8, okay, which once again is over the molar mass. So what is the molar mass of C3H8? From the previous problem, we already know that there are 44 grams of C3H8. So I know proportionally that instead of 3 times 12, I'm going to write it as 36. There are 36 grams of carbon in 44 grams of C3H8. So that proportionally would be the same as X grams of carbon in 82 grams of C3H8. So when you cross multiply these, what you get is that you get 67.1 grams, or rounded to the correct number of sig figs, 67 grams of carbon in 82 grams of C3H8. Alright, so in this problem, what we're going to be doing is, it says an 8.2 gram piece of magnesium combines completely with a 5.4 gram of oxygen to form a compound. What is the percent composition of this compound? So once again, I'm not asking specifics about magnesium or which specific element is the percentage of that element towards the mass. I am asking in general, hey, what's the percentage of magnesium towards this mass? What is the percentage of oxygen towards this mass? And so when trying to identify the type of this, what I'm giving you is I'm asking for the percent, but I don't know the specific compound, which is what happens in type 2, where you know what the compound is. In this case, I don't know the compound. What I do know, where I'm putting it into my formula, is that magnesium, so I'm going to solve for magnesium first for percentage, magnesium is contributing 8.2 grams to the total mass. Well, what is that total mass? Well, for this problem, it's 8.2 grams is coming from the magnesium and 5.4 grams is coming from that oxygen. So when I simplify this, I get 8.2 grams is coming from the magnesium and 13.6 grams is coming in overall. So that is proportionally going to be equal to the percentage over 100. So when I cross multiply and solve for this, I get 60.3%. Now I could just take 100 minus the 60.3 to figure out what the mass of my oxygen is, because for this particular compound it is only made up of magnesium and oxygen, and if it's not magnesium then the mass has to be coming from the oxygen. But what I'm going to do is I'm going to solve it the exact same way that I did the magnesium problem. And so for oxygen, I know that oxygen is contributing 5.4 grams out of the total 13.6 grams. This is exactly how you would measure out the percentage that you got on a quiz. For example, if you got a 5.4 and the total points was out of 13.6, what is your percentage? It's the exact same format. So we're going to divide or set it up equal proportionally of the percent over 100. So when you cross multiply, once again, you get 39.7, which is the exact same answer that I would have gotten if I had taken 100 minus that 60.3 originally. All right, hopefully you understand a little bit about percent composition for tonight.